In this video, we're going to walk through a simple example to show the importance of data modeling when using Power BI. Power BI is super powerful and it's very user-friendly, and new users can quickly bring in data and do analyses. And most of the time that goes very well. However, it is really easy for people that aren't familiar with data modeling to make bad models. And the irony there is, while it's really easy to bring in data and get to analysis, it actually pushes you to need more advanced DAX skills to work with a bad data model than with a good data model like a star schema. And so the more thought you put into and the better you get at data modeling, the less DAX you'll actually need to learn how to use. So I'm going to use a simple example of looking at some manufacturing line data, looking at uptime, and the incoming data is actually at the run level, and runs can last for more than one day, but analysis at the day level is needed. And so I'll show you what the DAX required for if you don't spend much time on data modeling versus when you do. So let's take a look at the data, and this is all just mock data. So, we just real simple mock data here. We've got a bunch of runs, 100 rows of data. Each row is one run on two different manufacturing lines, A and B. So 50 runs on each. And so each run has a start time and an end time. It may or may not be on the same day. And there's also a calculated column here that shows the duration of that run. Okay, and so if the only analysis you needed to do was at the run level, you could very easily do some great reports with this with no problem, and this would be a perfectly fine table to use. It's not a great practice to keep date times. Usually you should split those, but you could do run analysis very easily with this. However, this was a post in the community, and the person needed to do some day analyses, how many lines are running each day, and what was the uptime or downtime per day for each line. And so the data really doesn't lend itself to that. You can add, if we look at the model here, you can add a date table, and because our data table has start time and end time, but these are date times, I can't relate it to my date table. I'm forced to do a DAX expression that passes filters or works with a data model here that doesn't have any relationships, which automatically is going to make it more complex and probably less performant. However, it is possible to do, and so let me just show you how one might approach that with a DAX measure. And so, and I'll show you a simpler way in a minute, and this is just comparing the two to show that you get the exact same results. So it is possible to work with a data model like that. However, the DAX required is very complex. And so if I show you the measure that's used in this chart using that data model with the disconnected date table and this uptime table, if I show you this measure here, you can automatically see that it's pretty long. I've added comments here to explain each part of it. And the goal of this video is not to show how to do this DAX with this model. The goal is to show a much simpler way if you do make a proper data model. But just to run through this real quickly to see what's involved, basically, since I want to do day level analyses, I need to iterate over the date table, which has a row for each date, harvest the current date in the visual. So this visual is at the day level. So if I just iterate over the date table, row context gives me the date value for that date. Then I can go over and filter that uptime table for where the run start time, and I just use the int function here to just get the day part of it, is less than or equal to the current date I'm iterating over, and the end time is greater than or equal to that. So any run that includes this date. And then iterating over that virtual table to go and do a couple of different if expressions to say, if the run started on this date, then use the start time and I'm using the mod function here just to get the time component of that start date time. Otherwise, assume it starts at midnight of that day, right? So if this is a day into the run, we would want to start counting time of uptime from midnight. And then I do the reverse on the back end here to look at the end. And again, if it ends on that day, just use the end time. If not, go to almost midnight. And I can't put 24 here because then that would count as 0 there and you get the wrong number. And then basically subtracting those two things for each row and doing a correction here to add 1 more second in there for this case, and then returning the difference of those and then summing up for all those dates so that you could do week or month level analysis. So long story short is a fairly complex measure. It works. It gets you the correct answers. But this would be pretty difficult DAX for a new Power BI user to use. So let's talk about how this should be approached. So if I go over to the query editor, this is the original data, this uptime table. Again, we've got 100 rows, and we've got start and stop time and duration. Since we need to do day level analyses and we couldn't connect our date table to either of these because they're date time values, we need to create a column that has just date values to be able to do this. And so I'm going to walk through this second query, which obviously has more steps in it, and we're using the same starting source table. The first thing I'm going to do is split the start date time into a date and a time. Do the same thing with the end time. So this is a good practice to split these just to reduce the overall granularity of the table and save file space and improve performance. So I'm adding this custom column here that generates a list of dates between the start and end date. And so we just use the list.dates function starting at the start date. This duration.total days gives me the total number of days plus 1, so the number of items in the list, and then each step should be 1 day long, so I'm using the hard-coded duration function here. And so if I just look at the preview, this one starts on the 10th and ends on the 11th. If I go down here, this 14th to the 17th, you can see it generates all the list of dates there. And so then what I can do is I can expand that to new rows, and then that will give us a row for every day that this line was running or that run was occurring over. And so we see we've got that here, and our number of rows has increased expectedly. And from here, basically, we can come up with two new custom columns to say, what's the new start time. So basically, it's checking that, hey, if this is the day, similar to our DAX expression, if this date is the start date, then use the start time. Otherwise, assume it starts at midnight. Same thing for the end date. I can come up with a new end time. Again, where if the end date is this date, then use the end time. Otherwise, assume it goes to almost midnight. And again, I can't use 24 here. So then I can remove the other columns. And because I have a column here that has the date value and there's a row for every day of operation, I don't need my original start date and end date columns. I can just have a date column, and I have my now new start and end ones. So each run can, there's multiple rows for each run, and it goes from whatever the start time was on the day to midnight, or from midnight to the end time, and so you get all the values there. And while it's not necessary, you can write DAX that doesn't require a calculated duration column. In this case, I think it's a good idea to do that. And so in this case, it's just doing the difference between the new end time and the new start time. And again, if if it's one of those days that ends on the almost midnight, it's off by a second, then you can add that second in there to get the correct durations for that day. Okay. And then we just end with a change type to put it back to decimal. And now we have a different table here that's much better set up for analysis. So if we go back over to this, this bottom visual is the one using this new table. And if I go to the diagram view now, and this is the improved model, now that I have this date table, I can make this date column, I can make a relationship between my two tables. So I have a very simple star schema here, and it's much easier to do the analysis I need to do. And because I've already calculated the duration per day, the measure that I need is very simple. So if we look at the measure that's used in this expression, it's just a simple sum, right? So you can't get much simpler than that. So certainly learning to do the more advanced things in Power Query, like I showed with making the list of dates and expanding that to new rows. But it really starts out with having a strategy and thinking about, what's the granularity of the analysis I need? Do I have a star schema or not? And setting your model up for simpler DAX, and ultimately, avoiding scenarios where you have to be fairly good at DAX to be able to get the needed result if you start out with a bad model. Whereas if you take the time and have a good strategy for coming up with a good model, your DAX is very trivial and you get the result much easier.